Hello, class. So we'll be going through the lesson. But first off, just want to say I miss all you guys, and hopefully we can get back in the classroom and see each other next year. But first off, let's talk about what's more important: parallel and perpendicular lines. So first off, first question was, what do you notice about the red line and the blue line? If we go back here to a couple answers that we had, the first one says the red line stays in place while the blue line keeps moving up and down, which is accurate. That's what's happening. It's not really what we're looking for mathematically, but it's still not wrong. On the right side, though, we have the red line is staying still in the middle, and the blue line is moving up and down. Both lines are parallel. That is more what I was looking for, but any type of answer suffices there. If we go back over here to question number 2, when two lines are the same distance apart for their entire lengths, they are parallel. The red line is parallel to the blue line. Sketch a new line that is parallel to the red and blue lines. So all you have to do is sketch a parallel line, which I think we all know. Now, one of these is obviously a lot better than the other one, but I think I understand the point what you're going for there. When you guys do these assignments, try to put a little bit more effort than what's going on over here. That'd be awesome. Next slide. So which figure do the two segments appear to be parallel? Now, hopefully this wasn't too hard for you guys. A, B, C, D, we should have noticed parallel lines are same. Railroad tracks, like roads, going the same way. Figure 2 is not anywhere close to that. We had everybody actually get this one correct. So good job. Way to know your parallel lines. I don't think I had any slides for that. Yeah. So parallel line segments do not have to be directly opposite each other or the same length. So they can be different lengths. Knowing this, did you want to change your answer? Most of you got that correct, and the best answer I found was two lines appear to both be the same slope. This means that for as long as lines go on, they will continue the same path and likely will never meet until figure 2, where GH, I don't know what that means, the slightly different slope will meet after some calculation. Wow, we got some typos there. Okay, going back to activity. What do you notice about the red and blue line? So what is happening here? So are they straight parallel of each other? No, they are not. They are intersecting, so we know they're not parallel. That is the first thing we look for. Secondly, we want to find out the other P word, perpendicular. Are these lines perpendicular? No, they are not. They need to make an exact plus cross right down the middle. Otherwise, it is not what we're looking for, which is what we have. Oh, that was for the last question, not changing your answer. So they cross this time, so they aren't parallel. They're intersecting. The blue one still moves while the red one does not, which is exactly what is happening in this little super exciting video clip. When lines cross one another, we say that they intersect. Sketch a new line, must be parallel. This one, there's a little confusion on it. So this was not what we were looking for. We wanted the line to be parallel to the red one, but cross the blue one. So we wanted to kind of go across like this. So it went across the red, or look like this one, like that purple line right there. Parallel to the red, because it's like train tracks, and then it crosses. Not perpendicular, right? Because it's not straight up and down, but just because it crosses, it just has to intersect, not to be parallel. I mean perpendicular, sorry. What do you notice about the red and blue line here? Let's go back to some responses you guys had. Blue line is moving and intersecting with the red line. The red line, once again, is stationary. That is a great vocab word. Good job to whoever did that one. Perpendicular lines make a right angle with each other. The blue line is perpendicular to the red line. So we wanted you to draw a perpendicular line here. Now, is that perpendicular? No, it is not. Is the one left perpendicular? Yes, it is, and I like the little box. Over here, we had someone being goofy, put in line right next to each other, but is that still perpendicular to the red? Yes, it is, and parallel to the blue. Whoops, keep jumping ahead of myself. Okay, are the green and purple lines perpendicular? How do you know? No, they're intersecting because there's not a right angle. And yes, if you turn it sideways, it still makes 90 degrees. So this is still perpendicular. Now, do we know for 100% fact? No, we do not, because there's no little right angle here. So you can say yes and assume this, but if you said no because it doesn't tell you, that is fair, because they could be slightly off. It could be to 89 degrees, very close. So we don't know for sure. But in this question, it turns out that it is. Okay. So I got 30 seconds, so I need to wrap this up. Are these two perpendicular? Going to the answers, yes was the most common answer, but the correct answer is no, because they do not cross to form a right angle. We need to have that right angle form. If we were to keep drawing it, it would, but we do not keep drawing it, so it does not count. And then that was the last slide, and that is all that I have for you guys. Have a great day.